After authentication, in order to protect message security, Alice and Bob will need to establish a shared secret key for the session. This can be accomplished in several ways. Suppose Alice and Bob share a master secret key. Then Alice can use this master secret to encrypt a new key and send the encrypted new key to Bob. Or Alice and Bob can also use public keys to encrypt the new key. We say that Alice and Bob should establish a shared key for each new session. This is true even if Alice and Bob already has a shared secret key. Typically, Alice and Bob share a long-term secret key, and we call it the master key. For example, the master key can be derived from a password. For each session, Alice and Bob would use the master secret key to authenticate and establish a new key for the session. Then, all messages in the session are protected using the session key. The main benefit of using session key is that if the key is leaked or broken, the impact is limited only to the current session. Intuitively, the more a secret is used, the higher the chance that the secret can be leaked. Therefore, we should limit the use of the long-term master secret and only use it at the beginning of a session for authentication and establishing the session key. Here's an example. Suppose Alice and Bob already share a master key, KAB. The first 3 steps are just for Alice to authenticate Bob. Say Bob is a server. Then, both Bob and Alice compute the same session key that is based on the shared master key and something about the current session, so that the session key is both a secret and unique to the session. So, for example, they can add 100 to the master key and use the result as the key to encrypt R, which is a challenge used in this session to authenticate Alice to Bob. And the result of encrypting R using a modified master key is the shared session key. Alice and Bob can also use their public keys to exchange a shared session key. For example, Alice can send to Bob a key encrypted using Bob's public key so that only Bob can decrypt and get the key, and then signs the result using Alice's private key so that Bob knows that the key is sent by Alice. Or Alice and Bob can use their private keys to sign the public messages that they exchange in the Diffie-Hellman key exchange protocol. And this can prevent the man-in-the-middle attack. That is, when Alice sends Bob the public message, she signs it. Likewise, when Bob sends Alice the public message, he signs it with his private key.